Assalamualaikum warahmatullahi wabarakatuh. My name is AQILAH binti RAZAK. We are from Group Data Enthusiast and we'll be presenting our project, which is Tabung Haji Cost Prediction in 2026. So my part is the abstract, and the abstract outlines a research project centered on forecasting the cost of the 2026 Hajj pilgrimage in Malaysia using data analytics and machine learning techniques. It describes the use of historical economics and financial data such as GDP, inflation, unemployment, exchange rates, and actual Hajj package prices sourced from official platforms like Tabung Haji, the Department of Statistics Malaysia, and Kaggle. The study applies predictive models, specifically ARIMA, SG Boost, and Random Forest to identify key economic drivers and highlight the most influential factors affecting the price fluctuations. So the abstract also emphasizes the practical value of the findings in helping both future pilgrims and policymakers make better financial and planning decisions. Ultimately, the project seeks to determine which forecasting model performs best in terms of accuracy, with potential adaptability for future economic disruptions.
Moving on to the background of this project, Haji is one of the 5 pillars of Islam and is managed in Malaysia by Tabung Haji. Over the years, the cost of performing Haji has increased due to factors like inflation, currency exchange rates, and rising service charge. While Tabung Haji provides saving scheme and subsidies, rising costs still affect many Malaysians, especially those from lower and middle income groups. With the help of data science and forecasting method like ARIMA, we can now predict the future of Haji costs more accurately, helping both institutions and pilgrims plan better. Now, on the problem statement, many Malaysian Muslims are struggling to prepare financially for Haji due to rising costs and a lack of reliable prediction. Although Tabung Haji managed subsidy, there's currently no data-driven tool to forecast the future Haji costs. Without a proper forecasting model, it's difficult for individuals to plan their saving and policymakers to prepare appropriate support. So, our project is guided by 3 main research questions. Firstly is, can historical Haji expenditure data be used to accurately predict the cost in 2026? Secondly, how do economic factors like inflation and exchange rate impact the predicted cost? And thirdly is, how can this forecasting model help Tabung Haji and future pilgrims with better financial planning?
My name is SITI and I'll be presenting the hypothesis and research objective. So our hypothesis for this project is the Haji cost in the year 2026 can be accurately predicted using historical trends and economic indicators through machine learning models. And the next one is our hypothesis is as the inflation rate increases, the predicted Haji cost will also be rising. As for our research objective, the first one is to forecast the cost of Haji in the year 2026 using historical expenditure data, to evaluate how inflation contributes to the escalation of future Haji expenses, and lastly is to develop a prediction model that can help with financial planning for future pilgrims in Tabung Haji.
Now, moving on to the significance of our research, this study is important because it offers meaningful insights for future pilgrims, financial planners, policymakers, and institutions like Tabung Haji in Malaysia. Firstly, one major contribution is the deployment of predictive models using data science and machine learning techniques. By applying algorithms such as SG Boost, random forest regression, and ARIMA, this research provides a structured and data-driven method to forecast future Hajj costs. This model can help Tabung Haji and other stakeholders predict price trends, manage subsidies more effectively, and strengthen overall financial planning. It also introduces a systematic budgeting approach to religious travel, making cost estimation more transparent and sustainable. Secondly, this study helps identify key economic factors that influence Hajj pricing by analyzing variables like inflation, GDP, exchange rates, and service-related costs. We can better understand which elements impact the price the most, since this is valuable for financial institutions and government agencies to create strategies or revise support mechanism, ultimately making Hajj more affordable for Malaysian pilgrims. Lastly, the research aims to support pilgrims' financial preparedness. With more reliable cost forecasts, individuals can plan and save earlier, reducing financial stress associated with performing Hajj, especially during times of economic uncertainty. Having accurate predictions can help future pilgrims make better financial decisions and approach their journey with more confidence and peace of mind. So we are going to use 3 algorithm, which is autoregressive integrated moving average (ARIMA), which is a classical time series model suitable for capturing trends and autocorrelation in historical Hajj cost data. Parameters P, D, Q help make the data stationary and identify underlying patterns. And the next one is extreme gradient boosting (XG Boost), a powerful machine learning model designed for accuracy and speed. Excellent at handling complex nonlinear relationship between variables like GDP, inflation, and exchange rates. It can convert time series into a supervised learning format and prevents overfitting and using ensemble learning. And the last one is random forest, and assemble a model that builds multiple decision trees and average the result. It can model complex relationship without strict assumption or heavy preprocessing, and reduce variance and handles noisy economic indicators effectively. So in order to evaluate this model, we use three evaluation, which is mean square error, penalizes large prediction errors; mean absolute error measures average error in simpler terms; root mean square error, error in natural units, easier to interpret. So the next one is data cleaning, and the first thing we do is relabeling data. We clean the inconsistent data name, like remove extra spaces, rename ambiguous labels. As you can see in the picture above, you can see that there are many columns for exchange rate, since we are seeing exchange rate of Malaysian money to other currencies, and we are going to extract MYR underscore SAR only. And we then made variable names more meaningful for analysis and stakeholder to understanding. As you can see at the bottom, we have extracted some features from each data set to make it more to make it more understandable and give clarity to the analysis. And the next one is formatting and normalization. We standardize all data from all date formats and corrected inconsistency, especially in exchange rate data. We converted numeric columns to appropriate data types and removed non-numeric or negative values. As you can see in the picture above, we standardized the data for exchange rates. So for exploratory data analysis (EDA), we use two visualization, which is the line chart and the heat map, correlation heat map. So for the line chart, you can see that it is comparing Hajj cost to GDP over time, and it showed a clear pattern. In 2019, Hajj costs were above 30,000, but dropped drastically to near zero in 2020 and 2021 due to COVID-19 pandemic, which caused global travel restrictions and Hajj postponements. A steady recovery was observed starting in 2022, which costs rising again and stabilizing by 2025. This trend highlights the impact of global event on pilgrimage pricing and reinforces the importance of temporal analysis. So for the correlation heat map, it was used to identify relationship between the Hajj cost and economic indicators. The result showed strong positive correlation with GDP, which is 0.71, economic growth 0.71, and exchange rate MYR to SAR 0.63. Inflation rate and unemployment rate had moderate correlations. Interestingly, the unemployment rate correlated higher than expected, which is 0.68, suggesting deeper economic effects. Additionally, a high collinearity was found between year and GDP 0.95, which must be carefully handled in predictive modeling to avoid redundancy to model bias. For the last step of data cleaning is the ALYA treatments. For ALYA detection, box plots were generated to visually inspect extreme values. The plot indicated that inflation rate, economic growth, and unemployment rate had noticeable outliers beyond their whiskers, while GDP remained within a normal range, although the exchange range, MYR to SAR, didn't show clear visual outliers. Further inspection using the interquartile range (IQR) method was applied to catch any hidden anomalies. This ensured that even subtle inconsistencies were addressed, improving data integrity and the reliability of predictions.
On the evaluation metric, the firstly is the MAE, where MAE stands for mean absolute error. It's a common evaluation metric used in forecasting and regression models. It tells us how far off our prediction are from the actual value on average. MAE works by calculating the absolute difference between each predicted and actual value, then taking the average of those differences. The lower the MAE, the more accurate the model. It's a simple and easy to understand way to measure how well our model is performing.
So moving on to the mean squared error, which is the MSE. As you can see from the formula, it might look complex, but the idea is quite simple. So first, for each year, we take actual cost, which is Y, and subtract the predicted cost, Y with the hat. So this gives us the error for that single prediction. Next, we square that error. So squaring there's two important things, which is it ensure the error are positive, and more importantly, it gives much heavier penalty to a larger error. So for instance, 100 ringgit will become 10,000 ringgit, while an error of 10 ringgit only becomes 100. So the sigma symbol then tells us to sum all these squared error together. Then we divide by n, the number of years we evaluated, to get average mean of the squared error. So a large MSC value, like the one we saw from a RIMA model, indicates that the model had at least some very large prediction error. A low MSC, like for XGBoost, means the prediction error were consistently small across the board.
Okay, now I would like to explain to you how to calculate the evaluation matrix. That is the root mean square error. We call it as RMSE. It is very, very simple. You just have to square root all the MSE that you calculate before. Okay, now I would like to explain to you that how important RMSE. RMSE gives us a sense of how far prediction are from actual values on average in the same unit as the target variable. It is particularly useful in cost forecasting because it penalizes larger errors more strongly. These values confirm that the model performed well, especially considering the complex and multivariate nature of the data.
So to forecast the Haji cost for 2026, the first model was used, which is ARMA model, where it is a time series forecasting technique. We choose ARMA because it works well with historical numerical data and can model patterns over time. Then we train the model using clean data from 2019 to 2025. The model captures the cost trend and generate a forecast for 2026. Then it visualizes the result with a line chart where the red dots show the predicted cost for the 2026 year. As shown in the chart, Haji cost dropped sharply in 2020 and 2021 due to the pandemic, then increased again from 2022 forward. The ARMA model predicted a slight decrease in 2026, suggesting that the price may stabilize, and this forecast is useful for Tabung Haji to plan the future package and subsidy, and it also helps the pilgrim prepare their financially early. So in this table, it shows the comparison between actual and predicted Haji cost from 2022 to 2025. As you can see here, it started from 2022 and not from 2019. This is because the data from 2020 and 2021 had missing or zero value due to the COVID-19 pandemic, and there was not enough earlier data before 2019 to train the model properly. So to make sure the model had a reliable training set, we only evaluate the forecast starting from 2022. From the result, we can see that the ARMA model performed well in stable years like 2023 and 2025 with lower error, while it showed higher difference in 2022 and 2024, likely due to the price fluctuation and limited historical data. On the evaluation metric of the ARMA for Haji cost prediction, we evaluate the accuracy using MAE, MSE, and RMSE. So the average error was about 2,778 and the RMSE was around 3,568. This value shows that the model gives a reliable estimate for short-term forecasting and can support better financial planning.
So moving on to the XG Boost Haji cost forecast for 2026. So this is a different approach where instead of looking only at the past costs like ARIMA, this is like a multivariate model. So this means that it has been integrated critical economic data directly into the analysis, specifically Malaysia's GDP, inflation rate, and most importantly, the Malaysian ringgit to Saudi riyal exchange rate, which gives us a much richer, more context-aware prediction. So because of this, XG Boost model treats cost fluctuations as direct consequences of economic shift. It doesn't just see a dip and a recovery like Arima does. It learns to associate that cost recovery after 2021 with a specific factor like strong GDP growth and changing exchange rate. It provides the why behind the numbers. And this deeper understanding leads to a different conclusion. As you can see from the red marker on our chart, the model forecasts a nuanced upward adjustment for the Hajj cost in 2026, while RIMA saw stability. Attributes suggest that underlying economic pressure, even if small, will likely push the cost slightly higher, offering what we believe is more realistic financial outlook. Perhaps the most powerful feature of this model is its diagnostic power. It can actually rank the economic variable to tell us which one has the most impact on the final price. So, for instance, we can begin to answer whether 1% change in the exchange rate is more or less impactful than a one change in inflation. So, this is an insight that univariate model simply cannot provide. And finally, this diagnostic capability provides an actionable insight. Stakeholders like Tabung Haji can use this information not just to set a price, but to understand financial risk. It allows them to conduct what-if scenarios and see their budget might be affected by future currency movement, enabling much more strategic planning in fair subsidy allocation. So, in a sense, the XG Boost moves us from simple forecasting to a more strategic, explanatory analysis of Haji costs. XG Boost model errors are incredibly small, which is the largest being less than 20 ringgit. So this model demonstrates exceptionally high accuracy. Its prediction for historical years are nearly identical to the actual cost, showcasing a very powerful and precise fit. The high precision comes from XG Boost cost strength. It actively uses the economic data, our GDP, inflation, and exchange rate figure to understand the reason behind the cost in any given year. So, however, this is a critical point for any data scientist when a model performs this well on a very small data set. method is a strong indicator of something that is called overfitting. This means the model might have memorized the training data almost perfectly instead of learning a more general rule. So while this confirms the immense power of SG Boost, the relevance of our economic feature, it also means we should view the 2026 forecast with an understanding of this context. You can see the results are dramatically different. The MAE, the average error is just 20 ringgit, which represent a massive leap in predictive accuracy on the historical data. As for the MSE, value tells us that there were no large outlier errors in our prediction. Most importantly is the RMSE, can interpret in ringgit, which is less than 25 ringgit. So this is a very low error, indicate that our XGBoost model was able to create a near perfect fit of to the data it was trained on. This metric shows that the economic variable we chose are highly relevant for predicting hedge costs by including factors like GDP and exchange rate. So the XG Boost model was able to explain the price variation with incredible precision. While it is a near perfect fit, a strong validation of our material approach, it also suggests, as mentioned earlier, a high risk of overfitting.
Hi, my name is Nina Syahira and I will be presenting the Hajj cost forecast for 2026 using the random forest model. First of all, the random forest model we use is a multivariate prediction built using 100 decision trees, and each tree is trained on different subsets of the data, and their prediction are averaged to produce a final forecast. This helps to reduce the overfitting and ensures greater stability and reliability in the output. The model used five economic indicators that are GDP, inflation, unemployment, economic growth, and the exchange rate between the Malaysian ringgit and Saudi riyal. These factors were chosen because they strongly influence the cost of international travel and service, especially during Hajj. And you can see here the forecast Hajj cost for 2026 represented by the red dot on the graph, and it shows a moderate upward trend. This increase reflects not just inflation, but also the overall economic recovery and financial pressure following the COVID-19 pandemic. And this random forest model allows us to make sense of how these economic drivers interact, offering a prediction that is both data-driven and context-aware. Next, to evaluate the model's accuracy, we compare its prediction to actual Hajj costs from 2022 to 2025. As shown in the table, the predicted values are very close to the actual cost. For instance, in 2023, the prediction was just RM 177 off, while the highest errors occurred in 2022 with around RM 952, which is still considered low in cost forecasting. Low error values suggest the model learns historical pattern well. However, since predictions were made on the training data, results may reflect overfitting. And these results show that the random forest model successfully learned the historical cost trends and can be trusted to forecast future values. Next, we further evaluate the model using three standard metrics that are MAE, MSE, and RMSE. The mean absolute error is RM 384.20, which reflects the average difference between actual and predicted values. The mean square error is RM 255,466.56, and the root mean square error is RM 505.44, which shows the model's real-world error in the same unit as the Hajj cost. These values confirm that the model performed well, especially considering the complex and multivariate nature of the data. Its strength lies in the capturing subtle relationship between economic variables and actual costs. However, as with any model trained on limited data, there is a risk of overfitting. The model may have also learned some noise in addition to the actual pattern. Therefore, while the 2026 prediction is strong, it should still be interpreted with reasonable caution.
In conclusion, this study applies predictive analytics to forecast Hajj costs for Malaysian pilgrimage in 2026, addressing rising expenses due to inflation, exchange rates, and service fees in Saudi Arabia. Using historical data from 2019 to 2025 and macroeconomic indicators, the study tested ARIMA, SG Boost, and Random Forest models. SG Boost performed best, accurately predicting costs with low errors, while ARIMA struggled with abrupt changes, and Random Forest identified key cost factors. The findings are useful for stakeholders like Tabung Haji and policymakers in pricing and subsidy planning. Future improvement could include more granular economic data, advanced models like LSTM, and an online tool to help both institutions and pilgrims plan better for Hajj costs. That's all from us. Thank you.